Hey folks, welcome back for another episode of Code Club. In this episode, I'm going to show you how we can make this plot that was published by CNN last month using facet grid, using a lot of tools from ggplot2 in the R programming environment. As I mentioned, this plot was published as part of an article on CNN.com last month in response or investigation to claims made by Robert F. Kennedy, who is the incoming or kind of nominated incoming Secretary of the Department of Health and Human Services under Donald Trump. He has some interesting ideas about health, and one of those ideas is to remove fluoride from drinking water. And it turns out that putting fluoride in drinking water, which is fairly common practice here in the US, is controversial. And it has not just kind of controversial in terms of social factors, but controversial in terms of the science and whether or not adding fluoride to water actually improves tooth health in children and in adults. And so the idea behind this plot is that they went to Malmö University. That's, I believe, in Sweden. I might be butchering that. I'm sorry. And I'm sure I'm mispronouncing that. But they have an oral health country area profile project, CAPP. And so it's an open source website. I will put a link to this article as well as a link to that database down below in the description of this episode. And so I thought this was an interesting figure because they found 4 countries that do fluoridate the water and 4 that don't fluoridate their water. I might have said floor there. 4 that don't fluoridate their water. It's so hard to speak. Anyway, and they got data from about 40 years ago and then more contemporary data. And what they basically see and kind of their audience here is, the general public, but what scientists generally see is that whether or not fluoride is added to drinking water, it doesn't really show a marked improvement in tooth health compared to countries that don't fluoridate their water. This is a topic that's of interest to me because I live out in the country here in Michigan. We get our water from a well that's getting water from an aquifer below our property. We do not add fluoride to the water. I've got a bunch of kids. They all have just horrible teeth. And I don't know if that's, of course, my wife's influence. No, probably mine. Or if that's because there's no fluoride getting added to the water, right? Well, of course, it's not so cut and dry, right? We do have fluoride in our toothpastes, right? And I think our kids also get, special toothpaste that has extra fluoride in it to kind of compensate for some of that. And so this issue of whether or not to put fluoride in the water isn't as simple as national policies or local availability, right? I live in the US where we do put fluoride in the drinking water, but I don't have fluoride in my drinking water because we live on a well, right? And so the data are kind of clumsy, right? It's a mixed bag. And beyond that scientific question and my own personal stakes to this, I thought this was an interesting plot. Again, it is a line plot, and it is 2 plots being composed together. In today's episode, we are going to take this on using facet grid. There's some interesting components here that are not immediately clear how I would do this with facet grid, so we'll have to figure that out. And in the next episode, I will make the same exact plot, but using the patchwork package, which I've talked about in previous episodes, that allows you to take multiple plots and compose them together. We'll get going over here in our studio now. I have a script already started that I'm calling fluoride.r. You can get a copy of this script as well as all of the code that I am generating for today's episode down below in the description for this episode. You'll see that what I'm starting with is loading the tidyverse package as well as a tibble or tribble. The tribble is a kind of tibble, or maybe it's just a function to generate a tibble in a format that's a little bit easier to read than kind of what we typically do with a tibble. And then finally, I'm going to save this out as fluoride.png. with an aspect ratio that matches what was found in the original figure. So let's go ahead and load these first 2 statements to get our data loaded in. And I could go ahead then and take this tibble and let's go ahead and pipe it out to ggplot. So for our aesthetics, we'll go ahead and do x equals year, y equals dmft. Let's also do color equals, and it's going to be this last column, which is way too long, and fluoridates is hard for me to spell. So I'll go ahead and copy that and bring that down here. And I think that's good. Let's leave it there for now. And we'll go ahead then and do geom line. And yeah, let's start there and see what we get. I'll go ahead and run this GG save so we can see what it looks like as a PNG. So this is what we get, which is not what we want. That's a far cry from this. And so the problem is that for each value of fluoridates water, true and false, it's drawing a separate line, right? And so basically it's connecting all of the points that we saw within each category of fluoridates water. And so to make it go by country, we need to use the group aesthetic. We'll do group equals country. So now what we see is we have separate slopes, separate lines for each of the different countries. This actually would be much more along the lines of how I would prefer to visualize the data as a single plot, but we'll have to save that approach maybe for the next episode. So now what we want to do is pull it apart into two separate panels. We can do that with facets. So we'll go ahead and do facet underscore grid, and we'll do tilde to indicate the stuff on the left of the tilde, I think, is rows, and to the right are the columns. And so we're going to have two columns and one row. And so that then is going to be fluoridates. See, I can't spell it. Fluoridates water. Very good. So this looks a lot more like what the CNN version had. Before I go ahead and worry about flipping the order of the two columns here, let's go ahead and add the rest of our geomes and aesthetics. The other geome that we'd like to add would be geome point. That gets us our nice circles at the ends of those lines. Looking good, making a lot of progress. The other thing that we'd like to add are the country labels, right? And so that gets a little bit more complicated because if I go ahead and do geome text, then I'm going to get text at both the left and right side of those segments. Actually, I get an error because I need to add another aesthetic here, which would be label equals country. And so now, like I said, I have the country labeled at both ends of the lines, right? And this is not what we want. And yeah, it just doesn't look good, does it? So what we'd like is only to have the label at the left side of those lines. Let's take a step back now and think about how we can go ahead and do this. Basically, I only want to show the data for the earlier of the 2 years for each of the countries. And so I think what I'm going to do is go ahead and break this pipeline apart. And maybe in here, what I will do is I will save this to a variable. I'll call this DMFT data equaling that tribble. We can then do DMFT data, typing in to the line plot. Everything is still good. But what we want to do then is take DMFT data and filter it to only get the first value, the earliest year for each of the countries. So there's a few ways that we could do this. I said the word filter. I don't think filter is exactly what I want to use. Instead, what I think I'll do is slice min. And so slice min allows you to select a column that you want to return the minimum value from, right? So if I did slice min on year, this is going to give me Japan 1975, right? But I want the minimum year for all of the countries. And so to slice year, I can go ahead and add .by equals, and then I can say country. And it's not happy. And so I can't specify an argument named .by in this verb. Did you mean by instead? And so this is one of the challenges with using this by argument in the newer versions of dplyr, is that sometimes it's a period, sometimes it's not a period. So let's try that. And so now what we get is, in fact, the first year for each of the countries, right? And so that's pretty good. If we wanted to be a bit more specific, we could go ahead and look at the slice min, and this allows us to specify how many values we want to return. I think I could do n equals 1, right, to make sure that I'm only returning the minimum year. Okay, and again, that gives us our 8 countries going in there. All right, and so then here, let's do DMFT labels. All right, and so now what we can do in geome text would be to go ahead and do data equals DMFT labels. And so now we see that we have our labels on the left side of each of those line segments, and that is exactly how we want it to look. We will want to move the label off of the point, but before I do that, I want to get everything else looking good, because ultimately that's going to involve a lot of futzing and moving things around, and I'd rather do all of that at the same time. So let's go ahead and get rid of that legend. We can do that by putting in like show.legend equals false, but we have 3 different geoms. Normally I do that, but let's go ahead and do that with the theme function. We'll do theme and we'll do legend.position, and I think I can give it none. So yeah, theme legend.position equals none, with the none being in quotes, gets rid of that legend and cleans it up. Again, this is a bit of a brute force tool. This will remove all of your legends, whereas putting show.legend within each of the geoms will remove that component of the legend for you as you go through. So we're making great progress. The next thing I want to do is let's go ahead and put the titles on our plot. And so back up here, we can do labs, and we'll do title, and we'll also have a caption. So that's going to be the text at the bottom. So let's go ahead and grab this, and I can copy this and paste it in. And then for our caption, we can do the same thing. And I'll go ahead and copy and paste this in. And this naturally has some line breaks in it that I'm going to leave for now. We'll probably come back in the future and use some of that great ggtext element text box simple. I want to hold off on all that stuff for now. Very good. We now have the title at the top and the caption at the bottom. Looking good. Because I can't help myself, let's go ahead and get these titles formatted just right. The other thing, while we're dabbling in the labs function, is that the original didn't have a x-axis title or a y-axis title. So let's go ahead and remove those. And we can do that back up here within labs. We can do x equals null, y equals null. And then in theme, we can do plot.title.position, and then we can say plot, and that will format it on the left side of the plot. And we can do the same thing, I think, with plot.caption.position, yep, equals plot, and that will also put on the left side. But of course, as we've seen in our version, the caption is right justified by default. So we want to left justify that. So we'll do that, and we'll do plot.caption equals element. And I'm going to go ahead and do text box simple because I know that's what I'm going to need, because this very first line is very long, and it'll automatically wrap the text for us. So simple, and we'll do hjust equals 0. And because I'm using something from ggtext, of course, I need to come back up here and do library ggtext. Very good. Now you can see that our title is now left justified rather than being justified on the y-axis. And our caption is also left justified, as well as being left justified on the plot. So that's great. One thing I'm noticing is that it is concatenating the different lines together. And so what we could do is to modify the caption to put a line break in before that source and before that graphic. And so where did we have that? So that was, again, before source. We'll go ahead and then do BR. And so we're using HTML, and BR is the anchor for a break, a line break, right? And we'll do the same thing here. And I will say graphic Pat Schloss, and I'll say after Soph Warns. Okay. And so now we have the same line breaks that they had, and everything is left justified. Looking good. All right. So the next thing I want to focus on are our X and Y axes, right? And so it doesn't have the 0, but it starts at 0, I'll assume, and goes up to 10, and goes from 1970 over to sometime after 2020, probably like 2023. So let's go ahead and clean that up a bit. I'm going to go ahead and use theme classic to get kind of a lot of like that extra stuff out of the plot. So we'll do theme classic. So for our x-axis, let's go ahead and do scale x continuous. And then our limit will go from 1970. And I'm going to go ahead and put in NA. The NA will allow scale x continuous or ggplot or whatever to pick the upper limit based on the data. And we're going to also want to scale this to go every 10 years. And so we'll go ahead and do breaks equals seek 1970. We'll go to 2030. We don't have 2030, but that's okay. By tens, and I need a comma here. And so now you'll see that we have it starting at 1970 and going out. Of course, there is a bit of that expansion whereas theirs starts right at 1970. Hold on to that, and we'll come back to that in a minute. Now let's think about the y-axis that goes up by 2's from 0 to 10. And so again, we'll do a very similar thing here, scale y continuous, and we'll do breaks equals seek 0 to 10 by 2. And I'm not getting the 0. I don't want the 0, but that I'm not getting it makes me think it's not actually showing the 0 on my version. And so I think what it's doing, of course, is it's using the minimum value down here for, I think that's Japan, and then basically adding in its expansion factor to that. So I want to set my limits to go from 0 to 10. So back up here again, we can do limit 0, 10. Now we have our 0 on the bottom. Also, we can now, I think, go ahead and remove that expansion. So let's go ahead and do chord Cartesian, and we'll do expand equals false. We now have gotten rid of that expansion. It's on the y-axis, starts at 0, ends at 10. There's nothing before or after that. On the x-axis, we go from 1970 out to about 2023. I'm noticing that the true is getting clipped. We could say clip equals false, but why don't we go ahead and add a limit to make sure that we've kind of imposed our own version of expand. So let's double check that we know what the maximum value is. And so I'm going to go ahead and take DMFT data, and let's go ahead and do summarize max year. And so the maximum year is 22. So let's go ahead and use that to set the limit. So instead of NA, let's go ahead and put it at 2023. And so now we've got our point fully shown, not clipped, and it'll have the same limit on both the false and true facet. One little detail that maybe you've noticed is that they have a y-axis for both panels, whereas I only have a y-axis for the false panel, not the true panel. It's basically the panel on the left. And so I would like to have a y-axis for both panels. I don't remember how to do this off the top of my head, so let's go ahead and look at the documentation for facet grid. And if we look through here at the arguments, things that stick out to me would be things like margins, axes, axis labels, maybe drop. So let's look at these further down in the description of the argument. And so we can look at drop, if true, the default, all levels not used. Okay, that's not what we want. That's talking about the factors that are used to make the facets, not the axis. Margins, either a logical value or a character vector. Margins are added facets, which contain all the data. Don't think that's what we want. Axes determines which axes will be drawn when margins. The default axes will be drawn on the exterior margins. All X and all Y will draw the respective axes at the interior panels too. This is what we want. So I think we want to do axes equals all Y back up here in our facet grid. So we'll go ahead and do axes equals all underscore Y. Bingo! We now have our Y axis for both of the two panels. Awesome, we're doing great. Now what I want to turn our attention to is, of course, they have a very minimalist design to their facets, right? That everything is really gray except for the data. I like that a lot. I really like that aesthetic because it really helps the data to pop. Now, in this example, I would prefer that the colors had a bit more contrast, but hey, we won't worry about that right now. For now, let's get rid of this y-axis. And so how would we do that? Well, that's down here in the theme, and we can do axis.line.y equals element blank. And along the way, we're also going to want to remove the tick mark. So we'll do axis.ticks.y equals element blank. And so that has gotten rid of those tick marks, which is good to see. And now what we want to do is be sure to add in the grid lines. We can also do that down here in theme. We'll do panel.grid.major.y. Again, I always get the grid lines for Y and X confused. So if I get it wrong, we can always just change that Y to an X. Not a big deal. Element line. We did well. We chose the right one. And so now we have those horizontal grid lines. And our plot looks a lot like what the original plot looked like. Of course, there's still a fair amount of styling that we still need to do. The first thing that I want to do is let's go ahead now and flip the order of our two facets. they put the true category first and then the false, whereas we currently have it opposite. So if you haven't heard me say this in the past, the default order when working with things like facets or things that become factors, which are categorical variables with an order, the default order that ggplot will use is to use alphabetical. So the F in false comes before the T in true. So this is alphabetical, right? It's also numerically the right order because false numerically is a 0, whereas true is a 1. So we want to switch that, okay? So let's go ahead and we can do that way back up here, probably within defining our DMFT data. And I'll go ahead and make our fluoridates, see, I screwed that up again. Fluoridates water, a factor. And so we'll say, we'll have to do mutate. So mutate fluoridates water equals factor on fluoridates water. Hopefully I've spelled that right now that I'm copying and pasting it. And we'll do levels. We'll then put true and then false. And I added it rather than piping it. I've been doing so much in ggplot2 that I forgot to pipe it rather than add it. Running everything else then, we then see that we have true and then false, and we have things in the correct order. So we see Iceland, Italy, Japan, Iceland, Italy, Japan, UK, right? And then Brazil, New Zealand, Ireland, US. So good. We have all those things in the right order, and that looks great. Let's go ahead and modify the colors of our lines and points. I'm going to say that the fluoridates water is navy blue, whereas the not fluoridating water is Dodger blue. And so we can do that back up here within our scales. So I'll do scale color manual. We'll do breaks equals, and then I'll do false and true. And then we'll do values equaling Dodger blue and navy. So I think these colors match fairly well. The Dodger blue isn't quite right, I don't think, but I'm not going to worry about it too much. You could always go ahead and use the digital color meter dropper thing to figure out what the actual color is in these two plots, these two panels, but I'm not going to worry about that for now. All right, so now what I'd like to do is go ahead and also turn the text of our geom text to be gray. And so we can come back up here to our geom text, and I can do color equals gray. And so now we can see our text is gray. Maybe that should actually be a little bit darker. So why don't we go ahead and do dark gray? And it's a subtle difference, but I think it's okay. So we'll roll with that for now. To get the styling a little bit closer to what they have in the original, why don't we go ahead and shrink the point as well as the line thickness. And so back up here in geom point, we can do size equals, let's do 0.5. I think that might be the default, so we might have to fix that later. And then geom line, we'll also do size equals 0.5. If that's too thick, we can always reduce that number. If it's too thin, we can always increase it. Oh, and it's warning me about using size in geom line. I have been doing a great job of using line width instead, but I just forgot. So our points got smaller, maybe actually a little bit too small. So let's go ahead and bump that up a little bit. Maybe we can up the point to say 0.7, and our line was too thick. So let's take that down to say like 0.3. So I think that looks pretty good, matching kind of the thickness and size. Ultimately, you're going to be making your own plot, and you're going to want things to be the size that you want them to be, right? Anyway, now let's go ahead and shrink the size of the text that is going with that point, because once we get the size right, we can then move it to get it into the right position. So we'll again come back to geom text, and let's go ahead and do size equals, let's do 6, and we'll do size unit equals PT to get it to be points. All right, so that definitely got smaller, but maybe too small. So let's increase that just a bump. We'll maybe take that up to 8. And I think that's one too big. We should have split the difference, and let's do 7. Okay, I think that looks pretty good. So now we want to move the label off of the point. And for the most part, the labels are kind of to the left of their points. And we could use something like ggforce, but that's just too much work for right now. I think what I'm going to do is try to put all of my labels on the left side of the points. And so this long New Zealand is 2 words. So maybe what we could do with New Zealand is put a line break between the New and the Zealand. And we could do that probably back up here. We could definitely cheat. And I will modify that data there to put in that line break. I don't need to do both of them, but actually I do need to do both of them because when we are defining the group for drawing the line, the country names needs to be the same for both years. Good, so now New Zealand goes over 2 lines. It appears that the line height is perhaps a little bit higher than I want. So let's go ahead back up to our geom text. And we need to put in a line break here anyway. So let's go ahead and do line height equals 1. Not totally sure if that did anything. Let's maybe take it down to like 0.8. Yeah, and so that brings it down. And I think that's a pretty good separation of those 2 lines. Now we want to move everything over to the left. And so we can do that by modifying the X aesthetic. And so we had AES X equals year here. And so back up here in geom text then, maybe what we could do would be to do mapping equals AES X equals year minus, let's try 3. And so mapping is the default second argument, I think. I always forget. So it's helpful to put in the name. So if we look at the documentation, oh, actually, it's mapping and then data, right? And so if you don't know the order of the arguments, you can always put in the name of the arguments. All right, so we'll roll with that. And so I'm noticing with 3 that there isn't quite enough separation. Let's go ahead and bump it maybe 1 more year to the right because I have like Iceland sitting right on the point. Of course, Japan is starting to get clipped here. So let's go ahead and nudge it over to the left 1 more year. So we'll go -4. So I think that looks pretty good. The Italy is starting to get a little bit far away, as is the UK. I'm not going to futz with that too much because there's other things I want to talk about that. Of course, you could manually come in here and modify the X and Y position for each of these countries. I'm not going to do that, like I said, but I do want to see how we can get back the J and the A from Japan that's being clipped off, as well as the B for Brazil. And so we can do that back up here in Chord Cartesian. We can do clip equals off. That then allows us to see the data that falls outside of the plotting panel. So I'm thinking that this J is running into the 6 too much. And so maybe I will come back up here and let's bump it only by 3.5 years. And I think that looks a lot better. The downside here then is that the D kind of runs into the dot of New Zealand and that the D from Iceland is getting pretty close to it as well. Like I said, you can go through and you can make a separate tibble, kind of like what we did back up here, right? So we have this DMFT labels. Well, you could start modifying the X and Y aesthetics, the year and the DMFT value to get each of those labels just where you want them, to even kind of, more closely follow what the original developer Soph Warnes did. But I'm not going to mess with that. All right, because I'm going to mess with enough other things. One thing I'm noticing that I forgot to do was to go ahead and remove the 0 at the y-axis label. So let's come back to our scale y continuous. And I set my breaks from 0 to 10. And I think I heard someone say 2 to 10. So let's do that instead. And so now we don't have that 2 down here. And so I'm happy about that. All right, so now let's turn our attention to these facet labels because some of you are probably freaking out that Brazil, we can't see the top of it. So don't worry, we'll get there. So let's go ahead and convert this true and false to fluoridates water and does not fluoridate water. I'm going to do that with a special vector that I'm going to create that I will call my fluoridates labels. And so this is going to be a named vector that's going to have true and false values, right? And so this will then say fluoridates water. I'm going to copy and paste and change the formatting a little bit. And then the second will be does not fluoridate water. And so let's get all my spaces right. Does not fluoridate water. Okay. And so now we've got fluoridates water and it is upset. Why are you upset with me? So I don't think it likes me having true and false logicals as the names of seats in the vector. So I'm going to go ahead and turn these into strings. And so now if we look at fluoridates water, it's a vector that's got those names. And so what we can then do is come down in here to facet grid. I'm going to try to do this from memory. Normally I have to go do a lot of searching through Google to do this, but I think I got this. We'll see. So we'll then do labeler, and that's the name of the argument. Then we'll do labeler, and the name of the vector, Fluoridates labels. And we actually need to say what that equals, I'm pretty sure. And so then we'll do Fluoridates water equals Fluoridates labels. Hey, what do you know? I did it right. You'll have to trust me that I didn't have to look that up to get that to work right. All right, but now of course, our formatting is not quite right. We need to get it to be left justified. We need to get it left justified actually on the plot, not the panel as it currently is. We need to change the color of that label, and we probably need to make it smaller and bolded and colored. Did I say colored? And we need to get rid of that outside box. So let's go ahead and get rid of that outside box because that just kind of annoys me. So in here, we'll do strip. That's the name of the box above each of those panels. And we'll do strip background equals element blank. And that should get rid of that rectangle. And so now you can see we no longer have that background. We now see Brazil. Wonderful. Good to see you, Brazil. And so now what we can do is let's go ahead and left justify Fluoridates water. And we can do that with strip.text. We'll do element text. And we'll do hjust equals 0. And so that gets those left justified. It does appear to have a bit of a margin on the left side here because we can see that it doesn't quite go all the way up to that grid line. I guess if I turn back on the box, we could see that there is in fact a margin between the edge of the box and the edge of the text. So again, we'll get there. So the next thing I want to do is go ahead and color the text accordingly. And so think about how you would do that, right? We've got Dodger blue and navy. The first panel is navy and the second is Dodger blue. Well, if you're me, what you might think about doing would, within this element text, we might say color, because that's an aesthetic, right? We could do like Dodger blue, and then both of our labels are Dodger blue, right? So why not vectorize it, right? Like, so could we do navy and Dodger blue? So the left one is navy for Fluoridates water, and the right one is Dodger blue because for the not fluoridating water, right? But that doesn't work. That doesn't work. So instead, what we'll do is we will use element markdown, and let's go ahead and put the CSS styling within the labels. And so we'll make this element markdown, and I think I've got too many parentheses there. And we can then come back up to our labeler, and within here, we can then use the CSS styling with a span. So the span is the HTML tag. We'll then do style equals, and then we'll do color, navy. And then we'll back out of that span. And then does not fluoridate water. We'll do very much the same thing as we had up here, except instead of navy, we'll do Dodger blue. And then we'll do back out a span, and voila, we've got our colors to match the two factors. Now let's go ahead and make the font smaller and bold. Again, here in strip text, we can do face equals bold, and we can do size equals, you know what? I think that's about the same size as the countries. Actually, it's a little bit smaller, and the countries were at 7. Let's go ahead and put that at 6, and that seems a little bit small. Maybe we do want that to be 7. And I think that looks a pretty good size. They're using a different font than me, so that might be affecting things to some extent. So anyway, now what we want to do is we want to left justify it on the plot. And so in our strip text, we could add to this a margin argument. So we could say margin equals, again, it's T for the top, R for the right, B for the bottom, L for left. And I'm thinking about L. So if I put 0 up, and I screwed up, because this needs to be margin equals margin L0. And that got rid of like all of the margins all the way around. But what we'll see now is that our text is right at the edge of that grid line, right? And so we want to have some space between the text and the grid line, and we want to move things to the left. Let's go ahead and put in B for 10, and then let's do -10. And so we get that space between the bottom and the grid line, but you'll notice that we have lost the DO for does and FLU for the fluoridates water. And so this looks a lot like clipping, right? We saw the clipping down here with the J for Japan and the B for Brazil, right? And so I wonder if there's an argument within the strip themes for dealing with that clipping. So let's go ahead and look at theme, and we'll come down here to this long alphabetical list, and I think it's going to be in the section with the strip. And sure enough, look what I found. Strip.clip. So let's look for that down here. Strip.clip. And here is the description. Should the strip background, edges, and strip labels be clipped to the extent of the strip background? Options are on to clip, off to disable, or inherit, which is the default. So we want to put off, right? And so that is going to be another argument. So we'll do strip.clip equals off. So now we see that by using a negative left margin, we could move that title to the left and try to justify it on our y-axis labels, or actually on the plot, right? Before I mess with that too much though, I want to go ahead and shrink the size of that y-axis and x-axis font. You'll see that they are a bit smaller than what I currently have. They are also in gray. In here we can do axis.text, and I think both dimensions have the same size font. We'll do element text, we'll do size, and let's start with 7. Everything seems to be about 7 on this plot, and so that shrinks it down pretty well. So I'm going to go down a smidge more and make that 6. So maybe I should split the difference and make that 6.5, because that looks too small. So now, again, turning our attention to this label, we can go to the left just a bit more, and so let's do -12. And I think that actually does a really nice job of being left justified on the left edge of that 10. Noticing theirs is maybe a little bit further left. So who knows? Let's go ahead and do -13. And I'm happy with that. Let's bring it down just a hair. So we put the bottom margin at 10. Let's make it 8. I think that's looking good. While we're thinking about the axis text, why don't we go ahead and make it and our grid lines the same gray color. And so again, here for the grid, we'll do color equals gray. We can also make the line width a bit thinner. So we'll do line width equals 0.25. And then our axis text, here we could do color equals gray. So I think that 0.25 was the line width that we had been using. So let's go ahead and drop this down to 0.1. And I think that is a pretty good width. So our ticks and our axis line also need to be that same color gray. And so we'll in here then do axis.ticks.x equals element line color equals gray. And let's make that the same line width. So we'll do line width equals 0.1. And so now those ticks are gray. And let's then do the line. So axis.line.x, and we'll bring that down. I'm not going to change the line width because I want that to be thicker to match what they had. And so I think our line is maybe a little too thick still. So I think the default must be like 0.5. So let's make the line 0.25. So we'll go ahead and do line width equals 0.25. And I misspelled line width here. All right. So that's thicker, but let's make it a little bit thicker. And let's take that up to 0.4. So I think that's good. I'm noticing that their tick marks are a little bit longer. So let's go ahead and make those longer. And that we'll put up here with our axis ticks.x. So we'll do ticks.length dot x. I guess we don't have to say y or x because we're not using y tick marks. And then here we'll put unit. And let's go ahead, and I don't know what to do, but let's go ahead and say 10 pt as the unit there. And so those are very long. And so we could probably drop that down to, let's say 3. All right, they can be a little bit longer. So let's take that up to 4. And I think that looks pretty good. So I feel like their gray is a bit darker than our gray. And so maybe instead of gray, I'll go ahead and use dark gray for these line elements in the plotting window. And so I think those colors match a bit better. Of course, our country labels now are the same color as that line. So we can come back up here, and I know there's like gray and dark gray, but I also know there's grays between 0 and 100. So if I did like gray 90, that's pretty light. If I did like 1, that's basically black. So if we do 10, 20, 30, one of the nice things about this programming environment is that the color, if I put the name of the color, it then shows me the color in the background, right? 40, let's try 40. It's maybe too dark. Let's go ahead and make it 50. And I think that actually looks pretty nice. Yeah, I think that looks great. All right, so the main part of the plotting window, I'm gonna call done, right? Like I said, there's little things we could futz with like kind of the placement of the country name. I'm not gonna worry about that so much right now. You let me know what you think. You know what, we could even move things above the points rather than to the left of the points. I'm not going to worry about that. I'm going to make an executive decision, and I'm going to resist the urge to mess with that. But let's go ahead then and think about the title as well as the caption formatting. So for the title, that needs to be bolded, and it needs to be smaller, right? That the country needs to end right above, like between the N and the O, and does not. Ours is way off the right side. So we'll come back here to plot title in the theme, and we'll do element text, and then we'll do size equals 12, and we'll do face equals bold, get a comma there. So that's gotten it bolded. I think I got it a little bit smaller. So let's come back and shrink it down. Let's try 8. Okay, that's too small. And so let's take that back up to 9. And I think that's like dead on. That looks pretty good. I'm happy with that. Great. Now let's think about the bottom. And the bottom is kind of the same size font as our axes, and it's also the same gray, right? They also have an extra space between the note and the source. So let's go ahead and in our plot caption, we have this text box simple. We'll do color equals dark gray, and then we'll do size equals 6.5, and let's put this on a separate line. We're gaining on it. I think it could be a little bit bigger. We noticed that journals in their version scrolls over the side. So let's go ahead and bump that up to 7 and see if that does the trick for us. It does. We now have journals on the next line. We want to put a break in between journals and source. We've already got 1. Let's go ahead and put 2 in. HTML doesn't generally respect spaces, and so you have to put them in manually. And so that's what we're doing with this BR anchor. Good. And so now we have a space between the note and the source. Good. We need to have a bit of a margin, though, between the bottom of the plot and the top of the caption. So we'll come back to our plot caption, and let's add in here then margin. So we'll do margin equals margin, and we'll do T, and let's do 20, because it is a thicker margin. So if I put the plots side by side like this, and I think that's close enough. I'm not going to futz with it too much more than that. So I think I've done a pretty good job of duplicating the plot that was shown in that CNN article. Again, the main difference that I'm seeing between my version and their version is the placement of the labels. So I think some of the big points to drive home here was that we used the axes argument within facet grid to say all Y, so that we had the Y axis for all of these. I know sometimes when people see plots made with facets, they want to have the information on the X and Y axis for those internal margins, or these axes as they're being called, right? So that axes argument is a pretty cool tool. The other thing then is that I'm a big fan of left justifying the title of my plot to the plot rather than to the Y axis. And so we saw how we could do that with the labels and using the labeler within facet grid to get the margin to go to the left, but by default, it will clip the title. And so that we saw that we could turn off the clipping in that strip. So let me know what you think about how I did here and kind of your overall impressions of this figure. In the next episode, I'm going to try to make the same exact plot, but instead of using facet grid, I'm going to use patchwork. And you know what? I might even try to figure out how to get those country names put in the exact same spots that they had in the original. I just can't help myself. What can I say? So that you don't miss that episode, please make sure that you subscribe to the channel, and I'll see you next time for another episode of Code Club.